On this problem, we're going to find all possible rational zeros, then test to find the zeros that are actual zeros, factor it completely, and then we'll follow it up with graphing the polynomial. So to find the possible rational zeros, part A, what we'll do is we'll take the factors of -6 and divide them by the factors of 2. So x is equal to plus or minus the factors of -6 are 1 and 6, 3, and 2. The factors of the leading coefficient 2 are 1 and 2. Now we want to break this down and consider, we talked about this in a previous section, 1 over 1, 1 over 2, 6 over 1, 6 over 2, and continue in that way. So 1 over 1, 1 over 2, 6 over 1, 6 over 2 is 3, 3 over 1 we've already listed, then 3 over 2, and then 2 over 1, and 2 over 2. So 2 over 2 is just 1, so we will not list it. So here are our list of possibilities. With this list of possibilities, we're going to go through and we're going to test out to see out of that list if we can find one that works. So we're going to use this function f of x equals 2x cubed plus 3x squared minus 11x minus 6, and we'll test zeros in that function using synthetic division until we find one that works. So if we were to choose the number 1 from our list of possibilities, if we chose a positive 1, we would do synthetic division, and in that synthetic division we bring down the 2, multiply to get 2, total these up to 5, multiply to get 5. This ends up being subtraction to get -6, multiply to get -6, and then this totals to -12. So this is not a zero of the function, but what we have found is that when x is 1, y is -12. So we'll keep this in mind for our graph purposes, but we'll go back and we'll choose another number to test for synthetic division. So 2, 3, -11, and -6. Bring down the 2, multiply to get 4. Total up to 7, multiply to get 14, 3, 6, and 0. Since we got a 0 here, then that means that for our answer, if we were stating out our zeros, we know that x is 2 is a 0. Let's go ahead and continue with part C, and we can answer part B as we do that. Let's factor into linear factors, with our first factor being x minus 2. Since 2 was a 0, x minus 2 is a factor. Now we're left with 2x squared plus 7x plus 3. We will factor this out. So for part C, this is our factored answer, allowing us to find our zeros from here and here. We already got 2. From here we'll get -1/2, and from this last factor we'll get -3. So here are our zeros. This was the answer to part B. We're going to take those zeros and we're going to plot them on our graph. So as we take these zeros, we're going to plot them on our graph, and then we will continue from there. So let's go on over to our graph. Let's draw our x and our y axis. Okay, and let's plot our zeros. Where x is 2, we have a 0. Where x is -3, we have a 0. Where x is -1/2, we have a 0. We want to find points in between our zeros, so we have -3, -1/2. So a good point to test maybe would be -2, so we don't have to choose a fraction. if the x-intercepts are far enough apart. So a negative 2 is between those two intercepts, so let's choose that to test. Remember that our function was f of x equals 2x cubed plus 3x squared minus 11x minus 6. We said that we would choose x is equal to negative 2, so in synthetic division we'll use negative 2. Whatever the remainder is will be our y value for our graph. So what we have left is 12. So going back to our graph, we're going to graph where x is negative 2, y is 12. Let's go ahead and count our y values in increments of 2, since we don't have much space on my graph paper here. So this is going to be 2, 4, 6, 8, 10, and 12, and the same idea going down, negative 2, negative 4, and so forth. Okay, so we found the point where x is negative 2, y is 12. So we go x negative 2, y is 12. We also found earlier, if we look here, a good point between negative 1/2 and positive 2 is a positive 1. But if you'll remember, when we were working earlier, we tested positive 1. We found that we got negative 12. So when x is 1, y is negative 12. Now, remember, if we go back to our function that we were working with, our highest power was cubed, and we discussed in a previous video that if our highest power is cubed, then our graph is going to look like x cubed on the ends. So the ends will go down on the left and up on the right. So we know that this graph will go down on the left, it'll go cross through this point in here, and then it'll go up on the right. Now, to be more accurate, we could find our y-intercept where x is 0. So if we let x equal 0, looking back at our function, let's go ahead and find our y-intercept. If we let x equal 0, f of 0 is 2 times 0 squared plus 3 times 0 squared minus 11 times 0 minus 6. As you can see, each of these will go to 0, so this is a nice point to choose because it's very easily found by recognizing that it is the constant term of our function. So when x is 0, y is negative 6. So this point right here. So we'll cross through, turn back around, and again, as we predicted, we go down on the left and up on the right.